Hi dear students, today I will explain hybridization of central atom by using a small trick. So how to calculate the hybridization? First BF3, boron trifluoride. So boron is central atom. Boron which group element? 13th group element. So 1, 2, 3. 13th group elements contains 3 valence electrons. So 3 fluorines forms 3 bonds. So the hybridization is sp2 hybridization. So next BeF2, the central atom is beryllium. Beryllium which group element? Second A group element. That means number of valence electrons 2. So how many fluorine atoms? 2 fluorine atoms forms 2 bonds. The hybridization is sp. So final BrF3, boron bromine trifluoride. Bromine central atom. How many valence electrons are present in bromine? 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. So 3 fluorines forms 3 bonds. So the remaining 4 electrons are 2 lone pairs. So 3 bond pairs, 2 lone pairs. The hybridization is sp. 1 lone pair is 1p, 1 lone pair is d. So hybridization is sp3d. So easy to calculate hybridization. sp2 sp, sp3d. sp2 sp, sp3d. Answer A. So next here the number of lone pair of electrons, same model, XeOF4, XeF4, XeOF4. The central atom is xenon. Xenon, how many valence electrons? 18th group element. 8th A group means 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. So one oxygen forms 2 bonds because oxygen valency is 2. 4 fluorine atoms forms 4 bonds. So the remaining 1 lone pair. So hybridization sp3d2. Hybridization sp3d2 and the number of lone pairs 1 lone pair. So very easy. So XeOF4 has 1 lone pair. So next XeF4. Xenon, the central atom xenon 8 valence electrons 5, 6, 7, 8. So 4 fluorine atoms forms 4 bonds 1, 2, 3, 4. So remaining 2 lone pairs. The hybridization is sp3d2. So how many sp3d2 hybridization and 2 lone pairs? So answer is 1, 2, 1, 2. So answer is A. So remaining also check XeF2, xenon 1, 2, 3, 4, 5, 6, 7, 8. 8 valence electrons. So F2 means it forms 2 bonds. So remaining 3 lone pairs. So sp, p, p, d. Hybridization is sp3d. So how many lone pairs? 3 lone pairs. So answer is 1, 2, 3. 1, 2, 3, 1. Like this same XeF6 also. So here 6 bond pairs, 1 lone pair, because 8 valence electrons, 6 bond pairs, 1 lone pair, very easy. So easy to find the hybridizational number of lone. The next question from the following: identify the ions with the same bond order. Same bond order, we know that 14 electrons, Cn minus means carbon 6 plus nitrogen 7 plus 1. 7 plus 7, 14 electrons. Next N2 plus. So nitrogen, 2 nitrogens, 7 plus 7, 14 minus 1. Plus means minus, 14 minus 1, 13 electrons. So next O2 minus 2. So O2, oxygen 8 plus 8, 16 plus 2, 18 electrons. So finally N2, NO plus means nitrogen 7, oxygen 8, minus 1, 15 minus 1, 14 electrons. So these two are having same bond order. So Cn minus and NO plus. 1, 2, 3, 4, 1, 4. So option 1, 4. So option C is correct. So otherwise, if 14 electrons are there, bond order 3, 15 electrons, bond order 2.5, 16 electrons, bond order 2.5 decreases, 13 electrons, bond order 2.5, again 0.5 decreases. It is fixed value. 12 electrons, bond order 2, 11 electrons, bond order 1.5. Left or right, 14 electrons to left side or right side, 0.5 decreases. So next, highest covalent character is found in which of the following? Highest covalent character. Already we learn Fajon's rules. For the given cation, size of ion increases, covalent character increases. For a given cation size of anion increases, covalent character increases. So which one has more covalent? D. Very easy. The covalency of aluminum in AlCl H2O 5 times plus 2. What is the covalency? Aluminum is surrounded by how many molecules or how many atoms? 5 H2O molecules and 1 chlorine atom through coordinate covalent bond. So what is the covalency? 5 water molecules, 1 chlorine. 5 plus 1, 6. So answer D. Next, find the odd electron molecule from the following. Odd electron molecules means it is the octet rule limitations. Octet rule limitations are if the molecules in which the central atom has less than octet, if the central atom has expanded octet, and odd electron molecule. So if you take C2H2, C triple bond C, H, single bond H. So 1, 2, 3, 4, 5, 6, 7, 8. It satisfies octet rule. It is also satisfied octet rule. So it is not odd electrons rule. So it is not. C2H2 not. Second one, SCl2. So sulfur atom has 6 valence electrons already. 1, 2, 3, 4, 5, 6. So 7, 8. So it follows 8 electrons rule. So it is not odd electron molecule. So next third one. So nitrogen and oxygen. Nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. Oxygen has how many valence electrons? 6. So 1, 2, 3, 4, 5, 6. So nitrogen satisfies 8 electrons, but oxygen does not satisfy it. That means 1 electron is excess. That means it is odd electron molecule. So fourth one, N triple bond N. N triple bond N. So it satisfied octet rule. Fifth one, NO2. NOO. Nitrogen has how many valence electrons? 5. 1, 2, 3, 4, 5. Again, oxygens 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it is single bond, it is double bond, extra 1 electron. So it is also odd electron molecule. So how many odd electron molecules are there? NO and NO2. So answer NO and NO2. So next, which of the following is hypervalent? Hypervalent, if the central atom has more than octet, that is hypervalent. So for example, less than octet, that is hypovalent. Solution in this PCl5. So how many 5 chlorine bonds are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is hypervalent. Remaining all CH4, it satisfies octet. NO3 minus, it is also satisfies octet. But BF3 is hypovalent. BF3 hypovalent, PCl5 hypervalent. So not this. Okay, see the next question. Which of the following molecules does not exist according to molecular orbital theory? We know that according to molecular orbital theory, electrons are arranged in the various atomic orbitals. They are bonding molecular orbitals and anti-bonding molecular orbitals. First one, Li2. Li2 3 plus 3, 6 electrons. 6 electrons means sigma 1s2, sigma star 1s2, sigma 2s2. So what is the bond order? Bond order is equal to half into number of bonding electrons minus number of anti-bonding electrons. That is equal to half into number of bonding electrons means without star bonding electrons, star anti-bonding. So 4 minus 2. 4 minus 2 by 2, 1. So Li2 bond order is 1. If bond order is 0, that molecule is not exist. So next one, Be2. Be atomic number 4. 4 plus 4, 8. So sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. So bond order is equal to half into number of bonding electrons, 2 plus 2, 4. Anti-bonding electrons 4. 4 minus 4 by 2, so 0. So Be2 does not exist. If bond order is 0, that molecule does not exist. Be2 like He2. Bond order 0 does not exist. So answer B. You do this C and D. So next, identify the pair that is not isostructural. Iso means same. So not same structure. So first one, PCl5. PCl5, the central atom is phosphorus. How many valence electrons are present? Phosphorus 15th group element. 1, 2, 3, 4, 5. So 5 chlorines forms 5 bonds. So hybridization is sp3d. So structure PCl, Cl, 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 Cl. So the shape is trigonal bipyramidal. Hybridization sp3d, shape is trigonal bipyramidal. So next one, BrF5. BrF5. So the central atom is bromine. 7th group element, number of valence electrons 1, 2, 3, 4, 5, 6, 7. So 5 fluorine atoms 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So 1 lone pair. Hybridization sp3d2. sp3d2 hybridization 1 lone pair. BrF5. Br 1, 2, 3, 4, 5. 5 fluorine atoms. So remaining 1 lone pair. It is square pyramidal. The shape is square pyramidal but not trigonal bipyramidal. So different shapes. So answer not isostructural. So remaining all are same isostructural. CH4 hybridization sp3. sp3 hybridization tetrahedral. SiCl4 also tetrahedral shape. Both are tetrahedral shape. NO3 minus, both are having trigonal planar shape. CO3 minus to NO3 minus, both are trigonal planar. AlF6 minus 3, SF6, both are having octahedral shape. So these two are octahedral shape. So these two are tetrahedral shape. Tetrahedral. These two are trigonal planar. So answer different structures means not isostructural. So answer A. Okay, not this. One debye is equal to how many coulomb meters? So very important one. So 1 debye is equal to 3.33 into 10 to the power of minus 30 coulomb meter, capital C small m. So direct bit. So 10 to the power of minus 18 ESU centimeters. In electrostatic unit centimeters, 10 power minus 18. In coulomb meters, 3.33 into 10 power minus 30. So very important one. Next question, see, the dipole-dipole interaction energy between stationary polar molecules and rotating polar molecules respectively is proportional to. Stationary polar molecules is 1 by r cube, rotating polar molecules is 1 by r power 6. So it is also direct bit. Stationary polar molecules r cube 1 by r cube, rotating 1 by r power 6. So next, in CO2 molecule, the hybridization of carbon and oxygen atoms are respectively. So what is the shape of CO2 molecule? Linear. So C double bond O, double bond O. If carbon has 2 double bonds in both sides, adjacent to 2 double bonds, that hybridization is sp. So hybridization of carbon is sp. So next, oxygen hybridization is sp2. So sp and sp2. So sp, sp2. So answer A. So next one, hybridization of boron in diboron is. So we know that BH3, it is a boron. BH3 is boron trihydride boron. So if it is binding with another boron molecule, it forms diboron BH, H, H, B, H, H, H. This hydrogen bond formation with the boron, this hydrogen bond formation with the boron. That means these 2 electrons are involved in, these 2 electrons are sharing with these 3 atoms. Here these 2 electrons are sharing with these 3 atoms. These bonds are called bridge bonds. You know that in 13th group elements, how many bridged bonds are present means 2 bridged bonds. This bridged bond is also called as banana bond or tau bond. So banana bond or tau bond. So like this. So 2 bridged bonds are there. These BH, 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 BH last bonds, that means terminal bonds. 4 BH terminal bonds, 2 BHP bridged bonds are there. So here BH3 hybridization is sp2, but here one more bond is present, that's why it has hybridization sp3. In diboron, boron hybridization is sp3, but in bh3, individually in bh3 the hybridization is sp2. But in hybridization asked in diboron, so answer C. Okay, not this. Okay, so chemical bonding chapter PYQs are completed. So next we will discuss another chapter. Okay, thank you.